Okay, so this week we're really going to get our hands dirty with SPSS. I'm going to give you a data set to do a similar assignment like what I'm going to show you here. But obviously I want to show you how to do these things before I ask you to do them on your own. Okay, so what we have here, it looks like it's an Excel. It is an Excel, but it is not an Excel file. It is a comma separated values file, a CSV file. But Excel will read these into its program, but the extension will be a .csv for comma separated value. Here in Excel, the first row is the name of the variable, and you can see if you just click on it, these little outside lines in each column, it will expand the column so that you can read everything that's in there. So I'm just going to do that. And let's just take a look and see what we see. All right, so it says census year, and they are all from 2000. So really that's a useless variable. We'll leave it just because it's there, but it's a constant, so it's not really a variable because it's all 2000. So we're just going to leave it alone, but we could essentially delete it. One thing I want to show you in Excel is if I highlight the whole thing and I come over here and I click, don't do sort, because you have to be very careful with the sort variable, because you may sort this variable but then it no longer corresponds to what's next to it. And right now everybody in, or line 2 represents this male from who's age 44. This is what he makes. He's from Florida, etc. So if I click filter, it puts these little carrots in each column, and I can then click on it and I can select all, or I can just select the females. Now it will filter them out, but it's not moving people around. So all these females, the males are still there, they're just hidden for us to look at. And then one other thing, you can come down here, and in this data set there are 232 females, because that's what I have highlighted, out of 500. So then I can go back up to here, and then where am I? Female, and go back and select all and hit OK. Another thing I can do is I can highlight this and I can say view, and I can say freeze panes, and I can say freeze top row, which, we'll go back to home. Now as I scroll, the column header stays the same. So even though, let me scroll down, if I go down to the bottom line, just one thing you have to remember, even though it says 501, there are only 500 lines of data, because that first row is the variable names. Okay, so another thing I'm noticing is that the words are on the left side of the column, whereas the numbers are on the right side of the column. Okay, obviously age is tiny, but that's registered as a number. So when we upload this into SPSS, I'll show you what it means, but do pay attention, because sometimes you'll get into some aggravating things in Excel or in SPSS from Excel, and it doesn't always make sense the way it reads the data in, but you can fix it on the either in Excel or in SPSS, and I'll show you in SPSS. We just leave this filtered, and so what I'm going to do is I'm going to open SPSS. And everything always opens on my other screen. I'll pause it for a second. This comes up, and I'm just going to delete that. I'm going to bring this over from the other side, and I'm going to go to File, Import Data, and I'm going to come over to CSV Data. Okay. Takes a second. Oh, everything's over on this side. Here I am in week 4. All right, I'm going to click Census, because it's now looking for a CSV. I say Open, and what it's doing, it takes a second because there's quite a bit of data. All right, and it says first line contains variable names. That's auto-checked because that's how usually people do it. The delimiter between the values is comma. So this is what it really looks like in a text file. It says census year, comma, state, FIPS code, comma, total family income, etc., etc., and then it's just separated by commas. And what the computer will do is read these into columns for us. So we say OK. And we get an output page that says it's done what it said it was going to do, and then we get the data page. Okay, and everything looks fairly similar to what it looked like in Excel. Now, although because that first column is not counted as number 1, you will see actually 500 lines of data. Okay, and so some of these data that are were labeled NA in the original data set. Let me go back. So we have some zeros, right? And then we have some NAs. Let's look. Number 63 will be number 62 in the SPSS. Let's go look at that one. 62. All right, and so even though it said NA in Excel, it's got a little dot here meaning missing values. Now that's great. We don't want NAs. In fact, I will eventually ask you to get rid of them. But here in this total personal income, it did not do that for us. It actually brought everything over as NAs, which we'll have to handle. All right, so we have white, 2 major races, never married, single, all these words, right? So we go to variable view and we look. The census year is numeric, right? And we look across and it says it's scale. Great. State FIPS code is string, okay? And we look across and it's nominal, fine. Total family income is numeric, as it should be, and it's scale. Age is numeric, and it's scale. Sex is a nominal variable. Race is a nominal variable. Marital status, total personal income. Look at that. That's string. We want to put it as numeric. We're going to say okay, and we want it to be scale because it's numbers. It's not a written value. So let me go back, take a look at everything. Okay, and now what it's done, actually it's taken away all those NAs. Great. And it is labeled those as dots or missing values. Okay, so we have quite a few missing values on personal income and also on total family income. Now, just knowing what I know about data, it's probably not truly a zero, right? That this person has 0 family income. So it's possible that they actually said no, they have 0 income, or it's missing data. But we don't know because we didn't collect these data, so we're just going to go with what we see. Okay. So the first thing I'd ask you to do was to import the CSV file. So I'm going to turn that red because we've done it. Okay, so looking at this, I think I might change this slightly because I have recode all string variables into numbers and label. But let's look at the data set. All right, so we have state FIPS code is string. We have total family income and age is numeric, but we have total personal income as string. And if we go to data view, that's actually numeric. So we want it to be numeric. So we got some things going on here. So let me make this a little bit clearer. Recode all categorical string variables into numbers and label, or use automatic recode. And I'll explain what I mean by that. Okay, so what I mean is the states are a categorical variable. And what I want to do is I want to go into transform. I want to go into automatic recode. Let me reset. I want to bring state FIPS code. I don't know what the FIP is, but we're going to just say state underscore new, add new name, and we're always going to check this treat blank string values as user missing. And what that does is if we have a missing value, it will not code that as number 1 because we don't want that. And if we don't do that, it will do that. All right, so we do that and we get all of the states in alphabetical order coded. Now let's just look really quick. I'm just going to run a quick frequencies and see how many in each state do we have. So I'm not going to do it on the old variable. I'm going to do it on the new variable. And we're just going to look at this frequency table. I'm going to say, okay. So we had 5 Alabama, 7 Arizona, 1 Arkansas, 62 California. And we can kind of see the distribution of how many people across the country answered this chunk of the census data, because we only have 500 lines of data. But a predominant number of them, when you look at this, just really FYI, valid percent, cumulative percent, we want the valid percent. So 12% were from California. And it looks like the bulk of the people in this small sample of that larger census data are from California. Anyway, okay, so let's go back to the data. So we don't really care about the state FIPS code. We now have the state new, and number 9 stands for Florida. Okay, and so when we go back, we can see that it has coded all of those for us, which is nice. Okay, so the next thing we want to do is we want to, family income is numeric, age is numeric, sex. Okay, now sex is written in words, and we want to turn that into numbers. Now I could go here, I could go to edit, I could go to replace, I could type in male, replace with 1, and then I could do replace all, and I could do female, replace with 2, and hit replace all, and then I'd have to go into value labels and label it, and that's all fine, that's fine to do. Or we can go to transform automatic recode. Okay, so let's reset this guy. We're just going to do sex over here, call it sex underscore new, add new name. Let's just do that just in case. And now we have male and female. Female was first, it's alpha order, female to male. And then we go look at our data again, and we can see it's been coded 1 and 2. It's a lot quicker, and it's coded here. All right, let's do the other 2 variables. We're gonna do marital stat, oh no, let's do race general. So race general, we're gonna call race underscore new, add new name, leave that guy checked, okay. Okay, and we see we have American Indian, Alaskan Native, Black, Chinese, Japanese, other Asian, Pacific Islander, 2 major races, and white. So let me just show you. This is what happens when you take chunks of data. We have American Indian or Alaskan Native, but if you notice, we have no Alaska here. So that number is going to be pretty tiny. Okay. All right, so let's do the next one. Automatic recode. We did race, so we're going to do marital. Call it marital new. Spelled it right, okay, okay. And we have divorce, marries, such and such, married, spouse absent, etc., etc. Okay, so we go back, we've got our new variables. They're nominal, they're now numeric, and all that's good. Okay, so we've recoded all categorical string variables into numbers and labeled them or used automatic recode. Now it says run frequencies on marital new, sex new, race new. Okay, easy. Go here, we can do it from the output page. We're going to go to descriptives, analyze, descriptives, frequencies. Okay, we're going to do sex new, race new, marital new. If I just hold down shift and grab them all, bring them over, it's display frequency tables. It's really all we want. Okay, so I have sex new, race new, marital new. Now let's look at these. How do we read these? We have 232 females, 46.4%. The valid percent for this first one is the same, and obviously because there's only 2 categories and there are no missing values, the valid percent and the percent are the same. And then this cumulative percent, what it does is adding the remainder to the next category, so therefore we hit 100. But when we're looking, we always want to look at this valid percent, because sometimes there will be missing data and it will mess up your percents and your cumulative percent. So we want, well, it doesn't mess it up, but we don't ever need this one. So we just want to go here. Anyway, long story short. Okay, so I'm going to hold that one down, hold that one down, hold that one down, right click, copy, go into my document. I'm going to return a few times and then hit Control V and paste. Oh, and it does that annoying thing with the numbers. I'll show you a trick not to have it do that. Okay. All right, so that's the answer to number 3. Run frequencies on marital new, sex new, race new, and we've done it. Okay, now it says run descriptives, mean, standard deviation, max, min, range, skewness, and kurtosis on age, total family income, and total personal income. Well, let's handle total personal income. Let's go to the data. So if we go to total personal income, you can see that this is still a string variable. So let's go to total personal income. We're going to change string to numeric. We're going to say OK. And now we can go across. If we hadn't done that, let me just show you. We do leave it at string. I come here and scale is not even an option. So when that happens, look over here because you've got it coded incorrectly. So we're going to make numeric. We're going to come over here and we're going to call it scale. Okay, and now we've got everything coded the right way. And if you go look, all those NAs have gone away and they're on the right hand side. Okay, so the directions were to run a descriptives, mean, standard deviation, max, min, range, skewness, kurtosis on age, total family, total personal. All right, so let's do that. Back to the data. We're going to go analyze, descriptives on total family income, age, total personal income. And let's look at our options. Mean, standard deviation, minimum, maximum, skewness, kurtosis, and range. Say OK. And then say OK. And then we just get this one table with everything in it. We're going to copy it. We're going to come down here and let's hit return a few times. And then we'll paste it. Here we go. Auto fit to contents. It shrinks it. Okay, so that one's done. And then we can kind of clean that up a little bit. Now it says create histograms for total family income, total personal income, and age. Well, okay, so I'm going to click down a few. Same variables that we just did. I'm going to go back to the data. And here in frequencies, if I go to analyze, frequencies, let's hit reset. I want the total family income, age, and total personal income. If I come over here and click charts, I can click histograms. I don't want to show the normal curve, and I don't want the frequency tables. And so I'm just going to say OK. And it's taking a second to think. Now we have family income, age, and personal income. And again, I'm going to hold Shift, come down to the last one, right click, copy, come down here and paste it. Didn't do those annoying numbers. That's good. Okay, so create histograms has been done. Now create box plots for total family income by state. Same thing. Go back to the data. We just want total family income. So we're going to say, we can do this one of two ways. We can go to legacy dialogues and go to box plots, or we can go to chart builders and go to box plots. So let's go to chart builder. And what we get is this dialog box. And we come down here and we say box plot, and we just want simple. Drag it over here. And I've forgotten, I want family income by, let's not do that by state, let's do that by race new. Okay, otherwise we'd have a zillion. No, let's leave it at that. Let's do state first. Let me just show you what's going to happen if I do it by state. So here I am. Let's go state new and total family income on my y-axis. I say OK. Okay, so you can see that we have each one of these tiny box plots represents a state. So this may not be the best way to visualize those particular data. So we'll go to this dialog. I'm going to go back to chart builder. Let's toss back, no, not that one. Toss back state, and let's do it by race new. And it won't give us quite so many categories. Okay, so we have American Indian, Black, Chinese, Japanese, other, and then we have a lot of outliers. So let's copy that. Let's go to our assignment and we'll put it in there. Okay, now it says make a scatter plot of total personal income and age. Scatter plot. So let's go back and we're in this graph, we can go analyze, we can do, graphs, chart builder, or legacy dialogues. Either way works. Let's do the legacy dialogue and come down to scatter dot. I'm going to click simple scatter, and I want personal income and age. So we have age is a continuous variable. Let's put age in the y-axis and personal income in the x-axis. We'll do it both ways. Okay, so when we do it this way, we can see we have this weird floor, or rather wall. Let's do it the other way so I can show you what I mean. Okay, so the correlation was essentially what we're running when we do a scatter plot. The scatter plot is not different, it's just pointing in a different direction, but here it's makes more sense to talk about a floor, right? So 0 is our floor, although it looks like some of these have reported lower than 0. So we can run a descriptives on total personal income and see what's going on there. But you can see that it's bounded, right? So people, looks like the lowest age is 18 and the highest age is somewhere in the 90s. Right, and we have a few people who make a whole lot of money, but the bulk of the people are bounded within 90-something, 18, 0, and about 200,000 with these 4 outliers. Okay, so let's just copy that one. Doesn't matter which direction you do it in. Paste it. Okay, so we've done that. Get rid of the NAs in total personal income. We've actually already done that. Now we want to make a clustered box plot of total family income by sex new and race new. What does that mean? Okay. Clustered box plot. We're going to go do that one of family income by sex new and race new. Okay, so let's go to graphs. Let's do it in chart builder. All right, we're going to hit reset. We're still in box plot, but now let's look at this one. This is a clustered box plot. We're going to bring it over. We want total family income by sex new and race new. Okay, so when we do that, family income goes on the y-axis, and then we want to look at race, and we're going to cluster on some particular variable. So let's think about that. If we cluster on race, we'll have a bunch of different categories for males and females. Let's do it with race new on the x-axis and clustered on sex new. I think that'll be the cleanest way to present these data. And here we go. We have male and female. The females are blue, so we have, looks like no male Native Americans, only 1 or maybe 2 female Native American or Alaska Native, and Black or African American, Chinese, Japanese. Looks like we only have 1 male because it's the males are on the right, and so that's how you do that. So we'll say copy. We'll go here. We'll paste. All right, now it says create 2 new variables, one called monthly family income and another called monthly personal income, and run a descriptives for each. Okay, so how do I do that? Monthly family income. Let's go over here. Let's go to the data. Let's go to our variables. We have total family and we have total personal. If I go to transform, compute variable, I can take their total income and divide it by 12 to give us the monthly. So our target variable is, we're going to call this, we're giving it a new name here, monthly personal inc. We'll just do that. And we're going to say total personal inc divided by 12. I could use the keyboard here, or I could use my keypad on my computer. Say OK. Go back to the data, and now we have monthly personal income. And you can see 1,000 a month, 1,600 a month, 30,000 a month, etc. All right, we'll do the same thing. Let's go to the recall. Go to compute variable, and let's just change monthly personal to family. Except you got to spell it right. Family. And I can just go straight here, since they're named the same thing, just family income, total family income, monthly family income. Okay. Okay. And here we have monthly family income. All right. And so I have done that. And what else did it ask me to do? And then run a descriptive. So let's go here, and we're just going to do analyze. We'll go down to descriptives. I'm using that recall. Take these guys, toss them back, and just do these two. Hold down shift, bring it over, say okay. Right click, copy, paste. Might be too high. Let me bring here, paste. Come on, paste. I'm gonna hover, auto fit to contents, scoots it over. Now it says organize the output by sex new and run a descriptives on total personal income. Okay, so what do I mean by organize the output by? All right, if I go to data, I can go into split file, and it says organize the output by sex new, and what it's going to do is it's going to give me output for the females and the males without having to do anything else. I don't have to select or do anything like that. So let's look at the, I forgot what total personal income. Okay, so we're going to say okay for that. So now we've sorted the data, or we've kind of divided the data. And so now anything we do is going to be separated by sex until we go tell it to stop doing that. So we want to do descriptives, and we're looking, let's reset this, and we're looking at total personal income, and we're just going to say okay. And now you can see sex for female, sex new equals female. For the females, their average is 17,400, and for the males it's 39,008, which, as we know, men make more money than women, so it's not surprising. So we can highlight all that. We say Control C, come down here, and then Control V, and there we have it. Now it says now organize the output by race new and run a descriptives on monthly family income. So same thing. We're going to go here. We have to go back to our data, or we're going to say split file, and now we can just reset it. Organize the output by race new. Say okay. And now we're going to run a descriptives on, I think it was monthly family income. And say okay. And now we have all the way from American Indian all the way down, and we'll click here. I'm just going to hold down shift, control copy, put them all in here, control paste, and there they are. Now it says look at your clustered box plot and your frequencies of race. Is there a way you could clean these variables up? All right, so let's go look. So here's my clustered box plot. We have to go way back. I do believe we did, here we go, frequencies of race. So we have 3 Native American, Alaskan Native, 71 Black, 8 Chinese, 1 Japanese, 25 other, 13 other Asian or Pacific Islander. If we collapsed these guys, the 8, 1, 25, and 13, into one category and called it Asian, we would go from 8 categories to 4, I believe. 1, 2, all of these would be 3, 4, 5, which would make our clustered bar chart, or even our simple box plot, easier to see, and it wouldn't be quite so small. So the answer to that question is, let's go back down to the question. Is there a way to clean these up? It's called collapsing a categorical variable into smaller categories or fewer categories rather than having so many categories. So doing a box plot of all the states, we could see all the states all the way across. It's just too many. So we would We could maybe cluster the states into north, south, east, and west, or whatever. Now the last one, and this is going to be in your homework, play around with some of the chart builders and create a visualization I have not already asked for and explain what I'm seeing. And Google is your friend. It's not required, but it's bonus. Okay.